In this session, we will talk about the multiplication property of equality. We will use the multiplication property of equality when there is a number attached to the variable and when there is a fraction attached to the variable. After that, we will simplify and use the multiplication property of equality for linear equation. Let's get started. So if the numerical coefficient is a number, then we must divide on each side by that number. Let's look at an example. Negative 4y equals 8. In this case, the letter y is attached to the negative 4, which is my numerical coefficient. I must divide both the sides by negative 4 in order to make y isolated, alone. Let's go ahead and divide. When I divide negative 4 and negative 4, it will cancel and you will have a positive 1. Positive 1 times y is just a y. And when you reduce 8 over negative 4, you will get negative 2. And this is how you use the multiplication property of equality when there is a number attached to the letter. Let's try another example. 7z equals negative 21. As you can see, the z is attached to the 7, which is my numerical coefficient. So in this case, to get z isolated, I'm going to divide both the sides by 7. 7 divided by 7 will be 1. Negative 21 divided by 7 will give you negative 3. And therefore, z equals negative 3. Let's try some more examples. Negative 6p equals negative 14. In this case, obviously you see the numerical coefficient is negative 6. We'll divide both the sides by negative 6. Negative 6 and negative 6 will get cancelled. Other side, the negative and negative will also cancel, so the answer is definitely positive. In this case, the 6 doesn't go into 14 directly, but we have to look for a number which we can divide both the 14 and the 6 by. That number is 2. So if you divide 14 and 6 both by 2, you should get p equals 7 over 3 positive, because both the negatives will become positive on the right side and the left side. Let's try another example. Negative 5k equals negative 7. K is attached to negative 5. And that's my numerical coefficient. I'm going to divide both the sides by negative 5. The negative 5 and negative 5 will get cancelled. On the other side, both the negatives will become positive. But in this case, there is nothing common between 7 and 5, which means we cannot reduce it. We will leave the way it is. So k equals 7 over 5 should be your final answer. Let's try one more. 3x equals 0. 3 is a numerical coefficient. We'll divide both the sides of the equation by 3. 3 and 3 will cancel, get 1. 0 over 3 is simply 0. And therefore, final answer, I will just put x equals 0. Now let's look at what happens if the numerical coefficient is a fraction. In that case, we will make the letter isolated by cross multiplying. Let's see. Let me get the pen. So what you can do if you don't see any number underneath of 5, just put the 1 and we'll do the same thing underneath here. So the cross multiplying will be 1 times y is y and 5 times 5 is 25. Same thing, 1 times p is p. And 4 times negative 6 is negative 24. So we are cross multiplying the right side and the left side. And that's an easier way to get the letter isolated. Let's try a few more. Here's another example. You can put 1 underneath the negative 15 and let's start cross multiplying. So when I multiply 1 times negative 5t, I get negative 5t. And I can multiply 6 times negative 15, which will give me negative 90. Now, to make t alone, I have to now divide both by the numerical coefficient -5. So let's go ahead and divide both the sides by -5, which we did earlier. So after dividing, we can reduce the -5 over -5 becomes +1. Negative and a negative on the right side would get canceled. 90 divided by 5 should give you 18. Final answer will be t equals 18. Let's look one more example. 3k over 4 equals -21. Same thing, you can put the 1 underneath the -21 and cross multiply. 1 times 3k is 3k. 4 times -21 is -84. 3 is the numerical coefficient which I'm trying to get rid of so that k is isolated. Go ahead and divide both the sides by 3. 3 and 3 will cancel. You will have a k. -84 divided by 3 should give you -28 as your final answer. Now let's apply this knowledge that we learned, multiplication property of equality in the linear equation. Here's our first example. 5 times 3x plus 2 minus 10 equals 30. In this case, I'm going to use first the distributive property. 5 times 3x is a 15x. 5 times 2 is a +10. That's how I get 15x plus 10 minus 10 equals 30. +10 and a -10 will cancel each other out, combining the like terms. We end up having 15x equals 30. To make x isolated alone, we will divide both the sides by 15. 15 and 15 will get canceled. 30 divided by 15 should give you x equals 2 as our final answer. Let's try one more example using the property in the linear equation. 8 times x minus 2 minus x minus 16 equals 35. Again, because of the parenthesis, we will use the distributive property one more time. 8 times x, 8x. 8 times -2, -16. Negative times x, -x. Negative times -16 is a +16. After that, we're going to combine the like terms. 8x and -x should give you 7x. And -16 and +16 will cancel each other out. That's how we end up having 7x equals 35. Now I want x alone. 7 is a numerical coefficient. I'm going to divide both the sides by 7. Let's reduce 7 and 7 to get 1, and 35 divided by 7 should give you x equals 5. If you need again, you can repeat this session again.